So we are moving to the second case, that is considering a simply supported beam carrying a UDL of W per unit length over the entire span. So consider a simply supported beam AB. Consider a simply supported beam AB of carrying a UDL. So this is carrying a UDL of W per meter length over a span of L meter. Okay. This is the condition. So RA and RB will be the reactions. As in the first case, we need to find out what are the reactions. So first, in order to find out the reactions, you can write sigma Fy is equal to 0. In that case, it will be RA minus W into L, that is the effective load. Okay, RA minus W into L is the effective load, plus RB is equal to 0. So RA minus W into L plus RB is equal to 0. So from that we will get RA plus RB is equal to W into L. Let that be the first equation. Now we'll write sigma moment about A is equal to 0. That is, right side clockwise are negative, anti-clockwise are positive. So it is minus W into L is the load. Okay. Minus W into L is the load. It is acting at L by 2, L by 2. Okay. So it will be minus WL into L by 2 plus RB into L is equal to 0. That is minus W into L by 2 plus RB into L is equal to 0. From that you will get RB as W into L by 2. That is the second equation. Now substitute the second equation in the first equation. We will get RA also as WL minus WL by 2, which is equal to WL by 2. So RA and RB we got it as WL by 2. Now next we need to find out the shear force acting. So the shear force acting will be shear force at A. Shear force at A will be RA, which is equal to WL by 2. It's a small w, okay, WL by 2. Shear force at B. Shear force at the middle also, let it be C. Shear force at the point C, let it be C. It will be, shear force at C will be RA minus WL by 2. RA minus WL by 2. W into L by 2, that is the effective load here. So it is RA is again WL by 2. So it is 0. Then what will be the shear force at B will be, shear force at B will be, from left hand side we are considering. So it is RA minus WL, which is equal to WL by 2 minus WL, which is equal to minus WL by 2. Okay, these are the values of shear force. So if you are drawing the shear force diagram, drop down these. Okay, when you are drawing the shear force diagram, it will be at A it is WL by 2, positive WL by 2 at A. Then at C it is 0, so it is crossing. Okay, at B it is minus WL by 2. This is negative, this is positive. This is the SFT. Okay, so these are the SFT values. WL by 2 minus WL by 2, and it is at C it is 0. So these are the values. Now we are going to find out the bending moments. Bending moment at A. Bending moment at A will be 0 since it is a simply supported end. Bending moment at C. Bending moment at C will be Ra into L by 2 minus, here it is W into L by 2, minus W into L by 2 into L by 4. So it is Ra into L by 2 minus W into L by 2 into the distance is L by 4. So substituting the value of Ra is again W L by 2. So W L by L square by 4 minus W L square by 8. So it will be W L square by 8. Okay, that is the bending moment. Maximum bending moment will be at the center. Then bending moment at B also, since it is a simply supported end, it will be 0. If you are starting from the left end, you will get Ra into L minus W into L by 2. That is Ra into L is Ra into L minus W into L by 2, which is equal to 0. Ra is W L by 2. So WL square by 2 minus WL square by 2, which is equal to 0. When you are drawing the bending moment diagram, it will be the shape of the bending moment diagram. Here it is 0, here it is 0, here it is WL square by 8. So it will be a parabola. Bending moment diagram. Bending moment diagram will be a parabolic variation for UDL, and SFT will be a SFT shear force diagram will be a linear variation. Okay, for UDL SFT will be linear, but the bending moment diagram will be parabola with a maximum value of WL square by 8.